that is close enough to the actual thing that another company is using, or a higher expense precision product, I'm going to see what I can do to make do with a less precise, less expensive, less known property. If I can bend around what's available freely, it means my iteration time is faster. I'm not dependent on a single supplier. And so I will also do things like make my own equipment out of beer cans, because I happen to have them.
Gee.
So, if you want, in the great Julia Child tradition of cooking classes, if anybody wants to come up and help me pour something, I have extra rubber gloves for you. If anybody wants to volunteer. Yeah?
Not all at once.
Yep, come on up. So I'm going to have you help me count the wax. So this guy here. So high-tech equipment, always. So this mold has a feature running all around the edge where it's got a gasket, and so that's how I do the mold alignment, is that I just feel it until it stops, the two halves stop sliding against each other. I know that it's caught the gasket. And so this is ready to pour. So if you could pour that in here, just in a steady stream, and just be careful to slide. Go faster than that. And just keep going, keep going, keep going. So I tap the mold to try and eject any bubbles that are hanging on to the internal geometry, and you're good. You can stop it right there. Yep. Yeah, you can put it back on there. Yeah. Thank you.
Oh, no problem.
So I stop it when the funnel is filled and not accepting any more liquid. It's not a precision affair where if you don't stop it, things will explode. So I just play it by ear. The mold is also ventilated, so I don't have to worry about the pour affecting the bubbles that are in there. So wherever there is a place where the bubbles could be caught, I've ventilated the mold with just a little brass straw that's been sharpened to a point, and it creates a little air hole. One of the cool things about that is that the ventilated hole has a lot of surface area relative to how much wax is in there. It actually shuts itself off automatically. So as soon as the air bubble is gone and some of the wax starts pushing up into the ventilation hole, the wax freezes and doesn't go through anymore. And so it's actually a self-limiting ventilation hole. I really like that about these kinds of molds.
Did you mention where you got those molds, or?
These guys?
Yes.
So these guys were cast out of these guys.
Ah.
So I filled this with silicone, waiting for it to cure, and then I have this.
Oh, okay.
And so,
and how do you make those?
So I designed these in CAD. So I designed the glaucus that I wanted, this final shape. So that was my base CAD file. And after I finished designing that, I separated out the outside components from the inside components, so the shell from the internal geometry, and I can boolean them in CAD, just sort of take a block and subtract, the core from block, and be like, if I can pour another material into that block, I get that mold, or I get that core, this shape. And so I've worked in mold making and casting enough to know a good mold shape for a particular, like this particular geometry. The flat mold shape is sort of superior to laying it on its end and trying to cast in from here, because the wax has to travel a fair distance through the mold to do the full fill, so it'll cool down a lot along the way. And so it's just knowing mold making and casting, I developed a particular mold for that just by orienting the core in CAD, subtracting it from a block, dividing the block into a shape that I could get two nice halves, and then subtracted them from another block to generate this shape. And so it's a sort of confusing process because each component is a couple of generations away. When you print it, you're actually printing a mold.
Turn this off.
Yeah, it should actually go off. There's no reason to have it on.
Doesn't that burn you?
Oh, the wax inside of here is actually pretty cool now.
Oh.
So it's like hot bath water. And also, I've been doing this
Okay.
for so long. I sort of have cook hands for this. So this guy is crystallizing in again, the great Julia Child tradition. I prepared one before.
Chicken.
Yeah. So this is what it looks like when it comes out. And mold making and casting, unfortunately, is a lot of sort of, I would like to get the human error out of this process, but there are a lot of intuitive processes to mold making and casting where the design, unfortunately, has to do with how experienced you are in this particular flavor of mold making and casting, how waxes work, how silicones are going to cast, where the bubbles are going to be. And demolding is a similar dark art where you just have to have a sense for it over time. But fortunately, with demolding, I'm not going to mechanically change the part unless I break it with demolding, as opposed to, say, gluing two sides together. So that's what the part looks like on side one, and so now that I've got that ejected, I can just sort of go around it and eject side two. No guarantees that I'm not going to snap this thing.
How long would you have to wait for it to...
It takes about 15 minutes. So one of the things that you can perfect over time with this method is if you have, they're not too expensive on eBay, but if you have an infrared thermometer, it's really useful because the wax likes to be at a certain temperature, the mold should be at a certain temperature. If it's a really cold day, like it's cold in here, the molds will suck a lot of heat out of the wax. So if you just have a lab notebook and you keep notes on, got my best results or was dimensionally accurate when the wax was this temperature, when the mold was this temperature, and so you can take a heat gun and, preheat the mold to get it up to the right temperature. And those kinds of things are really essential for getting this process spot on. Unfortunately, with other shapes like the trefoil, like with the big tentacle shapes, they withstand a whole lot of error. They're sort of screw up tolerant. The glaucus having such narrow wall thicknesses and such a complicated shape, it's much, oh man. There it is. It's much less screw up tolerant. Oh well, I broke it. Since this isn't going to be a functional glaucus, nobody cares. But, so the way I repair these guys is I actually have a soldering iron that I turned into a wax pen. I just put a tip from the sculpting tool onto the soldering iron, and I'll put it back in the mold and solder the pieces back together, essentially, just melt the wax. But that is pretty much it. So that's the part.
How long does it take you to fix it?
Fixing it, if it's a really bad break, fixing it can take a while. This break is actually possibly not the kind of break that has to be fixed. So if the break doesn't lose any material, or if the break isn't, there are some areas that actually have to float a little bit above the mold that are unsupported. As long as the break isn't in a nightmare area, what you can do, so this is what I call the orientation half of the mold. So just a very, very quick and simple chemistry lesson. So inside of the silicone elastomer, there's a catalyst that's either tin or platinum in most of the two-part silicones that does the job of zipping up the elastomer, essentially causes that crystallization that happens that turns the silicone from a liquid into the elastomeric gooey solid that it is. That process happens in stages. The first stage where you'll notice things start coming together is called the gel phase. So the silicone will start binding up, and you'll notice it goes from being a liquid, a true running liquid, to start being this sort of coagulated egg mixture. As it gels, the catalyst is still active enough that another layer of silicone on top of that chemically bonds to the previous layer. And so you can get two pieces that are mechanically seamless. So what I do in this process is I take advantage of that. Instead of adhering two cured layers together, I actually use the catalyst still active in there to cast one side, let it gel, and quickly cast the other. And what that lets me do is put this complicated geometry, this complicated core, in a very specific place in the mold, and then I switch out the other half when the silicone is gelled and pour up the other side, and they zip together. And so here I am orienting the wax inside